guys, so what we're looking at today is lesson 4, parallelograms. So we're going to go into some details about parallelograms, sorry, can't talk today, and go through how to find the area of them, a few of their details and characteristics and things like that, okay? All right, so let's go ahead and jump right in. All right, so figures A, B, and C, so these top three are parallelograms. Figures D, E, and F are not parallelograms. So we've got examples and non-examples. So what do you notice about the number of sides a parallelogram has? Well, remember, A, B, and C are the parallelograms. So we've got 1, 2, 3, 4 sides, 1, 2, 3, 4 sides, and 1, 2, 3, 4 sides. So they all have 4 sides. Now, you might be saying, well, D has 4 sides and F has 4 sides. Yes, they do, but they're missing other certain characteristics that the first three have that they do not have. And obviously E has 6 sides, so it's just out there, not anywhere close to being accurate. So for the next question, it says opposite sides of a parallelogram are parallel and have equal length. So if we look at this, opposite sides. This side is 1, 2, 3, 4. This side is 1, 2, 3, 4. They're opposite. They have the same length and they're parallel. These two sides are never going to intersect each other. Same with these, same with these. So the opposite sides will never intersect and they're the exact same length. So that's what makes it so that they're parallelograms. Now in this case, this side and this side, they're going to intersect each other and they're not the same length. So that means it can't be a parallelogram despite having 4 sides. Now on D, once again, this side and this side are not the same length and eventually they are going to intersect each other. So once again, not a parallelogram. All right, and the next one says opposite angles of a parallelogram have equal size. So this angle here and this angle here are the same size, and this angle here and this angle here are the same size. Now in a rectangle, we know all the angles are the same, so the opposite angles are definitely the same. And this is a square, so the opposite angles, once again, they're all 90, so we know opposites would be the same. So rectangles and squares, I'm going to write this down. Rectangles and squares are special parallelograms. So rectangles and squares are parallelograms, even though they may not have the stereotypical slant that a parallelogram does, they still are parallelograms because their opposite sides are equal and parallel. The opposite angles are congruent, they're the same, and they have 4 sides. So they fit the criteria there, okay? So, area of a parallelogram. Find the area of each parallelogram, show your reasoning. So there's different ways to find the area of a parallelogram. One way is you could decompose it and rearrange. So we could take this triangle right here, cut it off, and move it over here. So we lined up the height, bring it over. This is 1, 2, 3. This is 1, 2, 3. So there'd be our base. And now this triangle over here would be gone. Well, now we have a square. So 1, 2, 3, 4, 5, 6 high by 1, 2, 3, 4, 5, 6 wide. So it really is a square. So 6 times 6 is 36. So this is 36 units squared. Now, another way would have been to draw a rectangle around all of this and subtract off our 2 triangles. You could do that as well. And we're going to look at another way, which is if we think about when we solve for the area of a square or a rectangle, we always multiply, oops, didn't write quite right. base times height. Now, in this case, the height is a particular height. It can't be the slanted height. It has to be the perpendicular height, which would be this height right here or right here. So we have to find what that perpendicular height is, so the one that forms a right angle. So if we use that in this next one, change the color, here is our perpendicular height because it forms that right angle. So our height is 1, 2, 3. And our base is 1, 2, 3, 4, 5, 6. So it'd be 6 times 3, which is 18 units squared. Now, once again, we could take this triangle over here and move it over here, give ourselves a rectangle, and then take and find the area. You would find that it's the exact same amount. Okay? All right, a couple more. So we have these parallelograms here, different ways to take and solve all of them. So you can use any method you'd like. I'm going to take and do multiplying base times height, so finding the perpendicular height and then multiplying by the base. So here, and just because it's height doesn't mean it can't be the horizontal. So this right here would be our height because these are our bases. They're not angled, so we wouldn't want to have to try and find this angled side as our base. So that's why these would be our sides and this is our height. So base and height. So here we have 1, 2, 3. So we've got a 3 by our base is 1, 2, 3, 4, 5. So 3 times 5, which gives us 15 units squared. Now on B, finding your actual vertical height, you have to do it outside of the figure. So it's going to be outside here like this. So we draw a dashed line on the outside. And yes, that's perfectly acceptable because our height has to go from one base to the other. So we can't just go up to, oh, there we go. That doesn't work because we're not going all the way from one base to another. So we have 1, 2, 3, 4, 5, 6. So we have a height of 6. And our base is just 2. So 6 times 2 equals 12 units squared. Once again, with this one, we could have drawn an entire rectangle around this and subtracted away the 2 triangles to find out what just this strip was here. That would work as well. All right, and the last one. Now, sometimes you will see not triangles. You will see parallelograms that look like this that give you this diagonal height. Never use this. You have to use the perpendicular height. You have to. Otherwise, your answer is not going to be correct. So if you get nothing else out of this lesson, you have to use the perpendicular height, okay? And that's what you need to know from this lesson is perpendicular height when solving for parallelograms for the area. So we're going to do 4 times 6, which gives us 24 units squared. So there's our area. If you would have done the 4.5 times 6, it would have given you a completely different answer and it would have been wrong. We don't use the slanted height for this. We use the perpendicular height, so the totally vertical or horizontal, depending on how your parallelogram is shifted, okay? All right, your keyword for this lesson is parallelogram. Parallelogram. If you have any questions, feel free to ask. Have a great day, guys. Bye.